Bright Tuty. Every student matters.
Let us now move to some practice questions. So here are some figures given. You can see 1 to 8. There are 8 figures given, and in this question we have to classify each of them on the basis of following. So the first one is simple curve. As we can see, first one is a simple curve because the curve does not cross itself. So first one is a simple curve. Second is also a simple curve because it is drawn without lifting the pencil of the paper. Now the third one is not a simple curve. Fourth one is also crossing. Fifth one, yes, it is a simple curve. Sixth one will also be a simple curve, and seventh is also a simple curve. Alright, now the next one, simple closed figure. So it should be simple as well as closed. So see, we have first, second, fifth, sixth, and again seventh. So same figures will be counted as simple closed figure because these are all closed from each end. Now polygon. Now we have already discussed the definition of polygon. It was a simple closed curve but should be made up of only line segments. So first one is only made up of line segment. Second one is also made up of only line segments. Rest, if I go to 5th, 6th and 7th, yes, they are simple as well as closed, but they have these curved lines. Okay, these are not made up of only line segments. Now convex polygon, we know convex polygon is the one in that the interior angle, each interior angle will measure less than 180 degrees. So we see it is only option number 2, because in one also we see this angle is a reflex angle. So this will not be a convex polygon. Now comes concave polygon. So first one will come under the concave polygon. This is how we are going to classify. So if the definitions are well clear to you, you can definitely identify what kind of a curve do we have. Let us go to another question now. The next question says, how many diagonals does each of the following have? First one is a convex quadrilateral. So if I draw a convex quadrilateral, so it is like this, and A, B, C, D is the name to it. Right, now they're asking how many diagonals. So we discussed what is a diagonal, that is formed by the two non-consecutive vertices. So we see A will form the diagonal with C and B will form with D. Right, so there will be how many diagonals? 2 diagonals in it. Also we have discussed the formula for the diagonals. So number of diagonals is calculated as n into n minus 3 divided by 2. Now a regular hexagon. So you can draw a regular hexagon like this. Regular means all the sides are equal. These all 6 sides are equal to each other. Now if you are going to draw the diagonals, how are you going to draw? A, B, C, D, E and F. Suppose these are the vertices. So from point A, you can draw diagonals to point C, to point D and to point E. That means how many? 3 diagonals you can draw. So similarly, each vertex will be able to draw 3 diagonals with the other one. Right? So total 3 plus 3 plus 3 plus 3. That means 3 will be added 6 times. So total have 18 diagonals. But suppose you have to draw a diagonal from point B. Now from point B, the diagonal will be drawn to F, then to D, and then to E also. But now you try for F. From F you will draw the diagonal to B. BF or FB is the same thing. So one diagonal will be counted 2 times. So we divide it by 2 and we get the answer as 9. Also using the formula, if we try n into n minus 3 by 2. So we have 6 sides multiplied with 6 minus 3, that is 3, divided by 2. So we again get 9 as the number of diagonals using that formula also. So drawing the 9 diagonals, the figure will be like this. Clear? For the triangle will be drawn like this with 3 sides. So we can name the vertices as A, B and C. So it will be like this. Now in this we see each vertex is adjacent to the another 2. A is adjacent to C and B. B is adjacent to A and C. So there will be no diagonals in it. Clear? I hope the concept of diagonals is well clear to you, and do remember this formula for number of diagonals so that every time you don't have to draw the figure and try out the diagonals. So use this formula to calculate the number of diagonals. Now let us go to another one. The question says, what is the sum of the measures of angles of a convex quadrilateral? So we have already discussed it. I'll also discuss in detail again, and they're asking, will this property hold if the quadrilateral is not convex? So that means if it is a non-convex, that means it is a concave quadrilateral. So still the property hold or not? So if we take, suppose, a convex quadrilateral like this, and let us name it as A, B, C, D. So we will divide it into two triangles and name the angle as 1, 2, 3, 4, 5 and 6. As discussed earlier, here we have two triangles, triangle ADC and triangle ABC, and we know in triangle ADC the sum of three angles, that means angle 1 plus angle 6 plus angle 5 is 180 degrees, and in triangle ABC we know that angle 2 plus angle 3 plus angle 4, the sum of these is equal to 180 degrees. That means the sum of angle A plus angle B plus angle C plus angle D, it is equal to 360 degrees. So this answers our first question, that what is the sum of measures of angles of convex quadrilateral. Now the second part that they are asking is, will this property hold if the quadrilateral is not convex? So let us draw a concave quadrilateral. So let it be like this, and we will name the vertex as again A, B, C and D. Now we will join B to D. We see that it is also divided into two triangles, triangle ADB and triangle CDB. We can apply the same concept like angle 1, this will be named as angle 1, this is suppose angle 2, this is angle 3, this is angle 4, angle 5 and angle 6. So we see in triangle ADB, angle 1 plus angle 2 plus angle 3 is equal to 180 degrees using the angle sum property of the triangle. In the second one, that is CDB, angle 4 plus angle 5 plus angle 6 is equal to 180 degrees. Adding these two, we get angle A plus angle B plus angle C plus angle D is equal to 360 degrees. So here also we are getting the same result as of a convex quadrilateral. That means the property will still hold whether the quadrilateral is convex or concave. The sum of interior angles will be equal to 360 degrees. Let us go to the next question now. The question says, examine the table. Each figure is divided into triangles and the sum of angles deduced from that. So as you can see from the figure and can draw a conclusion. Just see, the first figure is a triangle. Here the sides are written as 3 and the angle sum is 180 degrees. The second one is a quadrilateral having a 4 side and it is divided into two triangles, first and second, and it is like 2 multiplied with 180 degrees. 2 can also be written as 4 minus 2. 4 here is number of sides minus 2. Right? Similarly, in the next one we see it is a pentagon having 5 sides and it is divided into 3 triangles. So the sum will be 3 into 180 degrees. 3 can be written as 5 minus 2. 5 here is the number of sides. Similarly, it is done in the last one where we have 6 sides and the sum will be 4 multiplied with 180 degrees because it is divided into 4 triangles, as you can see. So it is divided into 4 triangles. So 4 triangles, each triangle the sum of angles will be 180 degrees. So it is multiplied with 4. So this will give us the total interior angle sum for this hexagon. And 4 can be written as 6 minus 2. So everywhere what we are doing, number of sides minus 2 we are doing. And we are multiplying it 180 degree so that we get the interior angle sum. Now they're asking what can you say about the angle sum of a convex polygon with the number of sides 7. So if the number of sides is 7, we will do 7 minus 2 multiplied with 180 degrees. That will give us 5 multiplied with 180 degrees. So it will be equal to 900 degrees. Now if the polygon has 8 sides, so it will be 8 minus 2 multiplied with 180 degrees. We get 6 multiplied with 180 degrees. So we get it as 1080 degrees. Now if the number of sides is 10, so we will do 10 minus 2 multiplied with 180 degrees. So we will get 8 multiplied with 180 degrees. It will be equal to 1440 degrees. Now they are asking if it has n sides, so it will be n minus 2 multiplied with 180 degrees. So what is the conclusion that they want us to draw is, we can deduce that if a polygon has n sides, we are asked to find out the sum of interior angle of it. The formula will be number of sides minus 2 multiplied with 180 degrees. So the final formula that we have is n minus 2 multiplied with 180 degrees, right? So this we can apply to all the polygons. Let it have 3 sides, 4 sides, 5 sides, any number of sides. Clear? Let us go to the next question, that is, what is a regular polygon? So we discussed regular and irregular polygons, right? So regular polygon means what? It should be equilateral as well as it should be equiangular. So equiangular means all the angles are equal. Equilateral means all the sides are equal. So they're asking us the name of a regular polygon of 3 sides. If a polygon has 3 sides, so definitely it will be a triangle like this. Now it should be equiangular as well as equilateral. All the sides are equal. That happens in equilateral triangle as well as with all the angles being equal. So ABC is an equilateral triangle. So what will be the name of that? Equilateral triangle, where all the sides, all the angles are equal. So it is known as a regular polygon. Now they are asking 4 sides. So if it has 4 sides, it will be a square. Square has all the 4 sides equal, these 4 sides equal, and each angle will be 90 degrees each. So a polygon which is a regular polygon having 4 sides, it is known as a square. Then they are asking 6 sides. So 6 sides figure is known as hexagon. So a regular hexagon, if all the sides are equal, all the angles will also be equal. So it is a hexagon. Clear? So these are known as regular polygons having all the sides as well as all the angles equal. Let us go to the next question now. The next question says, find the angle, measure x in the following figures. So the first figure is this. Here we have to find the angle x. As we have already discussed that the sum of these 4 angles will be equal to 180 degrees. We can easily find the measurement of this angle. So we can write 50 degrees plus 130 degrees plus 120 degrees plus x equals 360 degrees. So we are going to add these 3. So we will get 300 degrees plus x equals 360 degrees. Solving it, we get x as equal to 360 degrees minus 300 degrees, and the value for x is 60 degrees. So this is our answer for the first part of question number 6. Clear? Let us go to another one. In this also we have been given 2 angles 70 degrees and 60 degrees, and we have to find out x. So first thing that we can note is this angle is 90 degrees. So what about this angle? This will also be 90 degrees. Reason is a linear pair they are forming, right? So if one is 90 degree, another will also be 90 degrees. It is a perpendicular to it. This complete angle, if we mark like this, this is complete 180 degrees. If this one is 90 degrees, this will also be 90 degrees. Now, according to the angle sum property that we have also proved in the previous section, Sum of all the four angles of this will be 360 degrees. So x plus 70 degrees plus 60 degrees plus 90 degrees is equal to 360 degrees. Now by adding 70 degrees, 60 degrees and 90 degrees, we get 220 degrees. That is equal to 360 degrees. So we get x is equal to 360 degrees minus 220 degrees. Solving it, we get the value of x as 140 degrees. Clear? So this is how we are going to solve the questions of polygons where in a quadrilateral one angle is asked and the rest are given to us. Clear? So the final answer for the second part is 140 degrees. Let us go to the next part. The next part is C. In it we have to find out the measurement of x. So we see that this angle is given as 30 degrees. What about this angle? This is 70 degrees. We know the total sum will be 180 degrees. So if this much is 70 degrees, that means this will be 110 degrees. Similarly, if this is 60 degrees, this is going to be 120 degrees because this is a straight line angle and it is 180 degrees, the complete angle. Right? Now we know the measurement of all five angles, and we know in a pentagon the sum of interior angles is by the formula n minus 2 into 180 degrees. N is the number of sides, so 5 minus 2 into 180 degrees, that is 3 into 180 degrees, which is 540 degrees. So this is the sum of angles. So we will add 30 degrees plus 110 degrees plus 120 degrees plus x is equal to 540 degrees. So we have 260 degrees plus 2x is equal to 540 degrees. So we will get 2x is equal to 540 degrees minus 260 degrees. We get 2x 280 degrees. Solving it, we get the value of x as 280 degrees divided by 2. So cancelling it, we will get 140 degrees. So this is our answer for part C. So as I told you, first of all you have to find the sum of interior angles by the formula n minus 2 into 180 degrees, and then applying the angle sum property we can find the asked angle in the question. The last question is shown as a pentagon again. Here all the sides are shown as equal. As you can see, the symbol is made. This is for equal to. That means these all are equal to each other. If the sides are equal, it is a regular polygon. So all the angles will also be equal. So each angle will have a measurement as x. So x plus x plus x plus x plus x. So it will be equal to 540 degrees. We have 5x equal to 540 degrees. So x will be equal to 540 degrees divided by 5. Solving it, we get x as equal to 108 degrees. So each angle in this will be, that means in the D part, a regular pentagon will be 108 degrees. I hope the questions are clear to you. Let us go to the next question. The question says you have to find out in the figure x plus y plus z. So first of all we see the angle 90 plus x. So 90 plus x will be equal to, let us write 90 degrees plus x equal to 180 degrees because they form a linear pair here. So x will be equal to 180 degrees minus 90. So x is equal to 90 degrees. This is the first thing that we have calculated. Let us go to z. Now we know that z plus 30 degrees, this angle is again 180 degrees. It is a straight line angle, or we can say it is a linear pair. So z will be equal to 180 degrees minus 30 degrees. So z will be equal to 150 degrees. This is the second thing that we have calculated. Now let us try to find out y. Y can be calculated because y is an exterior angle to this triangle as seen. So y is equal to the sum of two interior angles, that is 30 degrees plus 90 degrees, right? y is an exterior angle to this triangle, right? Exterior angle is equal to the sum of two opposite interior angles. Interior angles are 30 degrees and 90 degrees. So we get angle y as equal to 90 plus 30, which is equal to 120 degrees. Now we know x as well as y and z also. We will be adding all of them. So x is how much? 90 degrees plus y is 120 degrees plus z is 150 degrees. Adding all this, we will get 360 degrees, right? So I hope the question is clear. We calculated x and z using the linear pair property, and we calculated y using the exterior angle property. Clear? So you can mention in bracket exterior angle property. Clear? So this is how we are going to solve the questions of this type. Let us move to the next question. In this also, we have to find x plus y plus z plus w. So we see that this is a quadrilateral and the sides are extended. Now we know the sum of all the four angles, all the four interior angles of a quadrilateral is 360 degrees. So we can write 60 degrees plus 80 degrees plus 120 degrees. Let us name this angle as t. So plus t is equal to 360 degrees. So t will be equal to 360 degrees minus, we will add all three, 60 plus 80 plus 120 degrees. We will get 260 degrees. So t will be equal to 100 degrees. So this angle is 100 degrees. Now because we know all these four angles, using the linear pair property, we can find out x, y, z and w. So first of all, we will write w plus 100 degree is equal to 180 degrees. So w will be equal to 80 degrees only. Let us solve another ones in the figure itself. If this is 60 degree, the complete is 180 degrees. So z will be equal to 120 degrees. If this is 80 degrees, what about y? Y will be 100 degrees. Right, because the complete angle is a straight line angle of 180 degrees. Using the same property, we can find out x. If this portion is 120 degrees, this will be 60 degrees. Let us now add x, y, z and w. So x is calculated as 60 degrees plus y is calculated as 100 degrees plus z is calculated as 120 degrees plus w, that we can calculate as, if this is 100, w will be 80. We calculated it, so it will be 80 degrees, right? We have to add these now. So we will get 360 degrees. That means the exterior angle which are there, whose sum will also be equal to 360 degrees. Clear? So this is how we get the value and the angles which are asked in the question. So this is there. Now let us go to some more practice questions. As we can see in this figure, we have to find out x. As we can see, this will be 90 degrees, right? So let us add all the angles. First of all, let us see how many sides does this polygon have. 1, 2, 3, 4, 5, 6. So it's a hexagon. Now the sum of interior angles will be n minus 2 multiplied with 180 degrees. N is the number of sides. So 6 minus 2 multiplied with 180 degrees. 6 minus 2 is 4 multiplied with 180 degrees. So multiplying it, we will get 720 degrees. Now that means the interior angle sum is 720 degrees. So we will add all of them. We will write x degrees plus 120 degrees plus 90 degrees plus 110 degrees plus, then we have 130 degrees plus 160 degrees is equal to 720 degrees, right? Also, don't consider this sign as equal to. I have just marked them to show you the sides, or count the line segments as L1, L2, L3, L4, L5 and L6. So these symbols were just made to count the lines, right? They're not equal. Now x degrees plus adding all these 5 angles we get 610 degrees equal to 720 degrees. Now x will come as 720 degrees minus 610 degrees. Solving it we get the answer as 110 degrees. So the measurement of angle x is 110 degrees. So this comes out to be 110 degrees, right? So by remembering this formula, calculating the total measurement of all the angles, we can find out the angle which is missing. Let us go with the another one. So here is another figure that asks you the angle of x degrees. As you can see, it is a concave. The formula will be n minus 2 multiplied with 180 degrees. So n is what? Number of sides. How many sides in this? This one is the first side. Let us just write 1. This is 2. This is 3. This is 4. And this is 5th side. So it's a polygon of 5 sides. 5 minus 2 multiplied with 180 degrees. 5 minus 2 is 3 multiplied with 180 degrees. And it comes out to be 540 degrees. Now let us add all these angles. 58 degrees plus 100 degrees plus 112 degrees plus 25 degrees plus x degrees is equal to 540 degrees. Now we will add all these. Adding them, we will get 295 degrees plus x degrees, and it is equal to 540 degrees, right? So now x degrees will be equal to 540 degrees minus 295 degrees, right? So this is what we have done. We have calculated the angle x. So what will be the measurement of x angle? 245 degrees. This will be the final answer for angle x. Clear? Obviously it would be more than 180 degrees because it is a reflex angle, right? So this was another question. Here is another question that says, what is the size of one interior angle of a regular nanogun? So if it's a regular nanogun, we know that the sum of interior angles is calculated as n minus 2 multiplied with 180 degrees. Nanogun means 9-sided polygons, and we are asked about the one interior angle, and it is regular. That means each and every angle will be equal. All the 9 sides will also be equal, right? So n minus 2, that means 9 minus 2 multiplied with 180 degrees. We get 9 minus 2 as 7 multiplied with 180 degrees, and it comes out to be 1260 degrees. Now this is the total sum of all the interior angles, and there are how many angles? 9 angles. So we are going to divide 1260 with 9 because all the 9 angles are equal. It is a regular nanogun. So the answer will be 140 degrees. So each angle will have a measure of 140 degrees if it is a nanogun, that means a regular nanogun, right? So this is how we do such type of questions.